So we have a couple gone today, so I can post that. All right, so on this first one, kind of running through this. We have a pollster will draw a simple random sample events from a large city to ask whether they support the construction of a new light rail line. Assume there are 1 million voters on the city and that 560,000 of them support this proposition. One voter is sampled at random. What is a sample space? So if I had asked you to list out all the sample space, what would you list out? We'd have to list out the 1 million voters, right? So the sample space in this one are the 1 million voters.
We're going to ask.
1 million of them. And then what is the probability that the sampled voter supports the light rail line? The one that we asked, what's the probability that he does support it? Right, so it'd be 560,000 over 1 million. I'm going to ask you on this test to answer everything in decimals. So we'll be consistent, and so in decimals, what is this? 0.56. So we'll say all answers on this test in decimals. Now, I will not ask you on the test to list these out. And in fact, I may try to get the formula sheet to you tomorrow so you can look at that, at least email it to you. But these will be on the formula sheet. So we'll say that these all are on the formula sheet. The hard part of this test sometimes is picking which one of these I need to use. So, you know, with A and B we have addition rules, right? That's for the OR statements. ORs. Now, the first one says, what is it if, for the general addition rule? So the general addition rule generally is for events that can happen at the same time, right? So the probability of A or B would be the probability of A plus the probability of B. That's why it's addition. But what do I need to subtract from that? Yeah, probability of A and B. Right, and of course, the easy way to think about this, what's the probability of, on cards, of drawing a king or a club, right? And so that those can happen at the same time. I subtract that A or B out. Now, on this one, if they're mutually exclusive, right, that means they can't happen at the same time. So that would be if I say I'm going to draw a card out of a deck, what's the probability of getting an ace or a king? And of course, we call those mutually exclusive events. They can't happen at the same time. This time, it's the probability of A or B. It's simply the probability of A plus the probability of B. And of course, there's nothing to subtract because there's the probability of them having at the same time is 0. The rule of complement says that the probability of a complement happening is 1 minus the probability of the event A happening. Alright, so as I look outside, I see it's all cloudy. If the probability of rain today is 20%, what's the probability of, what was the complement of raining? No rain, not raining. So what's the probability of it not raining? 80%, right.
Is it
It is rated 20% today, I believe.
No, it's going on. Really? Yeah.
Better chances are tomorrow.
Let's go.
Okay, the general multiplication rule. This is for dependent events. Dependent events means that one event affects the probability of the next event. So if your events are dependent, one depends on the other, then the probability of event A and event B. Remember, we're talking about multiplication. These are the ands. Well, this is the probability of A times the probability that of B, given that A has occurred. Dependent events. One event affects the next event. The probability changes because one event has taken place. And then if it's an independent event, right, then simply the probability of A and B is just the probability of A times the probability of B. So depending on the type of events is very critical to coming up with this. Okay, so let's run through the rest. Of this, I think, is just problems now. And some of this is listed out in data given. Some is pure theoretical. Okay, question 3. So we have the table we have here is results of a survey in which 400 college students were asked whether they listen to music while studying. All right, so basically, listen or not listen, and it's broken down by gender, male and female. So this would be all 400 students here. So A says, find the probability that a randomly selected student does not listen to music while studying. So I guess we first need to decide how many do not listen to music. We really should kind of add this amount up here, right? So 70 and 54 is how much?
54.
How much is this? Oops, I added that wrong. How about 132? So the probability, and work on your notation, of not listening is 132 out of how many? What's my bottom going to be? 400, right, 132 over 400. And, of course, that's 0.33, right? Everything has decimals. Okay, so B says, I'm probably that randomly selected student listens to music or is male. Here's an or. The or tells me what type of rule do I want. So if we think through this, the or would imply an addition rule. What do I need to conclude then to figure out which rule to use? Yeah, are they mutually exclusive or not? So can they happen at the same time? So you can have a male that listens to music. So that means we need to do the general one, right? Let's see. So that means that it'll be the probability. So that means the probability if we listen or of a male will be the probability that we listen plus the probability we're male minus the probability that we listen and male. Alright, so that's the general addition rule. So what's the probability that we listen?
268 over 400.
Alright, so we need to add this column up here. So 121 plus 147, that's 268, right? So that's 268. So this would be 268 out of 400, so there's more room. Probability of being male, we need to add these up. Male is what, 121 plus 78? 199? So this would be 199 out of 400. And then the probability of listing and male. 121? That's 121 males that listen. So, let's see, on all these fractions, same denominators, so I can take and add the numerators. And subtract the 121. I get 346.
Yep. 0.86.
So we won't leave like that. We divide that by 400, because I want decimals and everything, 0.865. So again, kind of the logic I had to go through, I had to decide that the probability of listening, I mean, probably I need the additional had to be the general, because these can happen at the same time. They're not mutually exclusive. And so I had to subtract that. Okay, 4 basically is a yes or no question. Are they mutually exclusive? Well, this is, the first one's pretty obvious. Those are following are yes or no on these questions. Let's see. A randomly chosen student is 18. The same student is 20. What? So what's that mean? Yes. Absolutely cannot happen at the same time. You're confused. So mutually exclusive means if they are, they're exclusive. They can't happen at the same time. So on the one we just did was not mutually exclusive. They could happen at the same time. You could be a male and listen to music when you study. But this is not. Yeah, this one's not. This one is, because you can't be 18, you can't be 20. On B, student owns a red car, student owns a blue car.
That could be.
That's possible, right? So you could own 2 cars. So this would be no, these are not mutually exclusive. Alright, on 5, get this one done, yep. On 5, in a group of 100 teenagers, 61 received their driver's license on the first attempt on the driver's certification exam, and 18 received the driver's license on the second attempt. What is the probability that a randomly selected teenager received their driver's license on the first or second attempt? So it's an or, right? And or means addition. You have to ask yourself then, are they mutually exclusive? So can both happen at the same time? Can you have a driver's license on the first and the second attempt? No, because you would not have a second if you had on the first. So we'd say these are mutually exclusive. That means we can use the rule that the probability of first or second is simply the probability of the first plus the probability of the second. There's nothing to subtract. So what's the probability again on the first try?
61.
61 out of 100. Second try would be 18 out of 100. So that would be 79. And that makes it very easy. I don't want that. The answer to be below 0.79. Okay. Okay. We probably should stop there today.